All right, so this time we're going to skip into the notes for 9-2 examples 1, 2, and 3. All right, so just to make sure that we're all on the same page here. So here we go, example number 1. So with example number 1, the function will be undefined. All right, so it's asking for points of discontinuity. All right, when we're doing points of discontinuity, I'm looking for wherever the function will be undefined. So to start out, it'll be undefined where the denominator, x squared minus x minus 12, is equal to 0. Okay? So now, to figure out where those are equal to 0, well, can we factor this? Can we solve this in certain ways to get my x values? Yes, I can. So it's x minus 4, x plus 3 equals 0. My two answers then is x equals 4, x equals negative 3. Those are 2 points of discontinuity. All right? So my points of discontinuity are 4 and negative 3. Not sure exactly what's going to happen there because I'm not doing the full analyzing for this. It's just asking to find the points. So let's go down to the next one. Where is the denominator equal to 0? 2x squared plus 4 equals 0. Ooh, this one I don't even have to factor. This one I can just solve for x squared. So I got 3x squared equals negative 4. Divide by 3. X squared is equal to negative 4 over 3. Now to get rid of this square, we take the square root of both sides. Taking the square root, we get x is equal to plus or minus. Now, I'm going to have this big thing inside of the square root here to start with. Now I can break this up. The square root of negative 4 is going to be 2i. So it's plus or minus 2i over the square root of 3. Now, the square root of 3, though, we need to rationalize. So it's going to go up top, plus or minus 2i square root of 3 over 3. So my final answer for that one, it's discontinuous at x equals plus or minus 2i square root of 3 over 3. Okay, but the question is, can I draw that on my graph? On a regular graph, no, I cannot. So this is not real. A real number so no points of discontinuity. Okay, so there's no points of discontinuity because the only ones that we could possibly get are imaginary. All right, so there's example 1. We're going to flip over to example 2. I'm going to leave the check understanding questions for you to work on for practice. Okay. Example number 2, finding vertical asymptotes. All right, so for finding vertical asymptotes, I'm looking at where my functions are going to be equal to 0. So the top one, a 0 that I would get from the numerator here, would be 7. X minus 7, set it equal to 0, I get 0 at 7. How about the denominator, though? Where do I get zeros? Well, I get them at negative 1, and I get negative 5. Are any of them the same? No. So then the zeros for the denominator will be vertical asymptotes because they're not the same. So since they are not the same from the numerator to the denominator, okay, then x equals -1 and x equals -5 are vertical asymptotes. Okay, so those will be vertical asymptotes then. All right, let's look at this next one down. This one looks similar to the one that I showed you for an example earlier. My zeros for the numerator here are at -3 and 0. My zeros for the denominator are at -3. All right. Since -3 is the same for the numerator and denominator, what happens? Well, -3 will then be a whole. All right? So x equals -3 is a whole. All right? And again, it's for the same reason that typically we would look at this and we'd say we could cross these out. We could cancel them out. X plus 3 over x plus 3, they're similar factors. They can get canceled out. But because they still exist in the original, we have to mark off that -3 was there. So x equals -3 has to be a whole. All right? And then our graph will look just like y equals x, just with a whole at x equals 3. Okay, so if I said that was at 3, that whole would be right about there. Oh, sorry, -3. Put it on the wrong side of the graph. My fault. Okay, -3. So at x equals -3, there's a whole, and that's our graph for it. All right, that's the end of the second video. Please try doing those check understanding questions. I'll be right back with the next one.